Are my slides visible to everyone?
Yes, ma'am.
Okay, thank you. So let's start the class. Good evening, everyone. I'm Rakhi Yadav, your PMRF teaching assistant for Introductory Organic Chemistry course, which is conducted by NPTEL and whose course instructors are Professor Harinath Chakrapani and Professor Neeraja Dashaputre from ICER Pune. So, students, in last week we have covered electrophilic aromatic substitution along with some basics of NMR, right? So, in this week, we are going to revise that part electrophilic aromatic substitution and we will learn more about nucleophilic aromatic substitution with its problem. Okay, is that student there who asked me why 13C range is 0 to 200 ppm and for proton range is 0 to 10?
Yes, ma'am.
Huh. So one answer was same, that one reason was sensitivity. Another reason is hydrogen have small nuclei, right? But our carbon has greater size-wise nuclei is greater. Nearby carbon, electronic effect is more pronounced than hydrogen nuclei, right? Understood? Nuclei of carbon is affected more with respect to hydrogen in terms of electronic change. A small electronic change brings more changes in carbon nuclei rather than hydrogen. Understood?
Yes, ma'am.
Okay. So let's start with this. So if we recall week, we have seen where the incoming electrophile will come in electrophilic aromatic substitution. So I was telling you that if benzene ring is attached with any electron donating group like OH, NH2, means any species which is having lone pair, right? So obviously it will invite the incoming electrophile at two position. One is your ortho and one is your para, right? In presence of electron withdrawing group, we will have incoming electrophile at meta position. I hope you know this thing. So, who is going to tell me answer of first? Just tell me one, two, three, four. Just tell me where the incoming electrophile will come. Tell me the position among these four possible position. Take your time and tell me.
Second position.
And one more thing before starting class. I want everyone to take part in this quiz. It will help you, okay? No matter if you are wrong, but try to answer the question. I am requesting everyone. You can ask your doubt in between, but try to solve. Huh. One student was answering. What is your answer? Second.
Yes, ma'am.
Okay, second. Another answer. So, how to start solving this type of question? Write OCH3, write NO. According to OCH3, where electrophile can come? Fourth and second. Yes or no?
Yes, ma'am.
And with respect to NO2, fourth
And
and second.
and second.
Both are similar, but more whenever you are having substituent like 1 2 position, their relative position is 1 2. Third electrophile will not come here due to sterics, right? So most
Yes, ma'am.
probable position is position number 2. Yes or no?
Two.
Very good.
Yes, ma'am.
Huh. So same in second, where electrophile will come? Okay, we will just tell me as per OCH3. Uh, okay, before that, OCH3 is electron donating or electron withdrawing?
Electron
Electron
donating.
donating.
Very good. Electron donating group. So it can invite incoming electrophile at two position, either ortho, either para. Yes or no? So if ortho para, let me number one, two, three, four. If ortho para, one, four, two. Okay. And if we listen to nitro group, then where can electrophile come? Tell me the position.
T.
Three and only three, right? Because their OCH3 is blocked. Due to OCH3, that C3 position to nitro is blocked. Yes or no? So
Yes, ma'am.
no match between these two substituents. If we are having two groups, electron donating as well as electron withdrawing, whom do we listen for electrophilic aromatic
Electron
substitution?
donating.
Very good. Why? Because here electrophile has to come. It will listen to electron donating one. Very good. OCH3. Okay. At position number 1, it will not come due to sterics. Now remaining position are 2 and 4. Which is more probable position?
Of
4.
four.
Very good, very good. Why? Because second position is nearer to NO2. And if we see
Yes.
one more effect of NO2, that is minus I. Minus I will be less at position number 4. Yes or no?
Yes,
Are
ma'am.
you with me, everyone?
Yes, ma'am.
Yes, ma'am.
Good, very good. Now, third, who will solve? Okay. Para position is blocked. One thing is clear. Let me again number one, 2, 3, 4. Now tell me. One
Ma'am
thing.
at 1 and 4th position.
Both are actually equivalent, right? So very good. 1 and 4th. So this is the product. Are we correct? Wait a minute. Here they have attached electro. Okay, I have numbered it 4. Okay, okay. Clear na? Let me erase this part. I hope everyone is clear. If not, I can discuss again. See, two position, two position. We are right. Understood? Can we move to next slide?
Sure,
Okay,
ma'am.
okay. So, problem number 1 for today's session is the increasing order of reactivity of the following compounds toward electrophilic aromatic substitution reaction. Your options are following. You have to tell me which one of the following is most reactive towards electrophilic aromatic substitution. Since electrophile is coming, you have to see more the your benzene ring is electron rich, better it will be reactive for your incoming electrophile. Keeping this thing in mind, tell me the answer.
Option C.
Option.
Yes, ma'am. Option C.
Everyone is with option number C. Okay, students are saying option number C. I have to check. I don't know the answer. Okay, how to start solving these questions for those who are not able to solve. See, benzene ring, let's say its effect is 0. Okay, nitro minus M minus I. Phenyl ring, no effect but plus R, or we can say that resonance effect. Chlorine minus I but plus M. But for halogens, their minus I is
Dominant over
dominating.
plus M.
Very good, very good. So if we keep these things in mind, which one is ahead? Third. Okay. Okay. So third is in front only in option number C. So our answer is correct. But why this is correct? Second is at last because minus M group is there. Yes or no? Fourth minus I, and first one is neutral. So correct answer is option number C. Students, is there anyone who is still in confusion? Understood now?
Yes, ma'am.
Okay, good, good. So this is subjective problem for you. Problem number 2 is you have to prepare compound 1 starting from benzene. Okay, you have to. You can take one, two, or three step. In one step, you can't form. You have to use electrophilic aromatic substitution starting from your benzene. How can you reach to this molecule? Would you like to solve or should I start? Or you want hint for this question?
Yes, ma'am. Some hint.
Some hint, okay. One hint is there. If you want to convert your NO2 group to NH2, what reagent we can add? If you don't know, let me tell you.
Mention reduction.
H2PDC reduction. Or another things are also there. For example, you have read in your 12th class book, right? In NCRT, what reagent was there for conversion of
Ma'am, zinc amalgam.
zinc amalgam? Okay, another in 12th class book. Okay, uh, you all are
Ma'am,
B- you all are BSc student or MSc or mix?
BSc.
BSc, everyone. हाँ. So I will teach in that way na कि after knowing your level I will teach from basic. Okay. So if you are BSc student in 12th class you must have read how to convert in nitrogen chapter. Have you could you recall that tin in presence of HCl or iron in presence of HCl? Anyone?
Yes, ma'am.
Yes, and H2PDC can also do the same work. Okay, this was your hint. What happened? Okay. Student, I can't see that Teams, sorry, Meet for screen. If you have any doubt, just unmute yourself and then ask. Okay. I can't see your raised hands. Hmm.
Okay, ma'am.
Okay, now tell me. Okay, you just try and tell me. I will do. No matter if you are wrong. Just tell
Ma'am,
me.
first chlorination will take place, then nitration with concentrated H2, SO4 and HNO3. Then we'll get nitro substituted benzene. Then we'll reduce this.
Okay, one answer. Another. Can anyone tell me what is the problem in her reaction sequence? What she has told us?
Ma'am, chlorine is orthopara directing, so it will not give meta product,
Very good.
maybe.
So now what is your answer? Very good. Okay. Let's start by benzene. See, one thing you have to check is in your product your substituents are meta, right? Huh. Your NH2 is orthopara. Your chlorine is also orthopara. Okay, so one thing is clear that one substituent has to be meta directing in order to get these position. Yes or no? Okay,
Yes, ma'am.
let me explain again. There are two substituents, they are meta to each other. In order to get 1 3 substituents, one substituent should be meta directing. Okay, but here both are ortho para directing. So, what can we do to convert one of them to a meta directing group? That I have given hint that you can convert NO2 to NH2. So, one thing is clear, you need nitrobenzene to start with. Okay,
Yes, ma'am.
these type of problem solving session will help you in clearing your competitive exam also, students, like jam and all, whatever target you have.
Okay, ma'am.
So this pointer is not working here, huh? So how will you convert benzene to nitrobenzene? In
Ma'am,
last
it
class, I
reacts
have
with
told.
HNO3,
Nitrogen saturated
H2SO4,
sulfuric acid
Very
and
good. This mixture, nitration mixture, HNO3, H2SO4. Now,
H2SO4.
what can I do? Tell me. Friedel-Crafts or what? Not Friedel-Crafts actually. Cl2 in presence of AlCl3. Yes or no?
Yes, ma'am.
It will give us meta product. Now the things are clear. What we will do? H2PDC. Understood?
Yes,
Students?
ma'am.
Okay, okay. So what you have to do, your homework from this slide is you have to prepare this compound starting from benzene. Can you do? Please note in your notebooks. You have to prepare this compound, this acid derivative from benzene. Okay, you can do it as your homework, but can anyone tell me how will you start this problem given in right bottom corner?
First, start with ma'am nitration of benzene.
Okay, then, okay, let's see. He is saying nitration. Then, okay, you have to do it as your homework. If you are not able to do, no issue. We will discuss in next class. Okay. But you know everything for this question. You know how to bring halogen to aromatic rings. You know how to bring nitro. But I think you don't know how to bring COOH, right? But
yes, ma'am.
but you
Yes,
know
ma'am.
how to bring COCl or not COCl. What you can call it your aldehyde group. Yes or no? Okay. You can use any reaction. You can use this reaction also. I don't know if it will help you. But if you do oxidation or toluene, what you will get? Acid only. I'm just giving you hint which reaction can help you. CHO oxidation, benzaldehyde. You can get your acid. Okay, hint. Okay, let's move ahead. Problem number 3. Which combination of reagents used in the indicated order with benzene will give you meta-nitropropyl benzene? Students, have you attended last week's lecture?
Yes, ma'am.
Has
Yes,
anyone
ma'am.
attempted the assignment?
Yes, ma'am.
In that,
Yes, ma'am.
one question is like this. Okay?
Yes, ma'am.
So try to solve this. I hope my problems are helping you in solving assignment. Yes or no?
Yes, sure, ma'am.
If no, you can ask me from there also, assignment also. Okay, I will solve. Okay, they are asking which combination of reagent used in this order with benzene will give you meta-nitropropyl benzene. So for your first task is draw the structure. What they are saying meta-nitro, okay, meta-nitro propyl benzene 1, 2, 3. I think this type of question we have also covered in last session. Yes or no? Okay, they are saying first nitration and then this Friedel-Crafts alkylation. Okay, then they are saying this alkylation and your HNO3 H2SO4. Then they are saying this. Okay, before solving this question, I myself tell you that answer is option number D. But now, can anyone tell me why option number A, B, C could not be correct answer? Who is going to tell me why
Ma'am,
option? Only one student can tell me. Okay. Okay. First one, and one girl is answering.
ma'am,
Why?
in A, after nitration, nitrobenzene cannot go Friedel-Crafts alkylation,
Very
so
good. Very
it
good.
will not.
I'm expecting same answer. Sh- She is saying that once nitrobenzene gets formed, right? You can't do Friedel-Crafts alkylation and get this product because now this ring is deactivated. Deactivated means it has decreased electron density of benzene ring. So you can't invite external electrophile. Okay, yes or no? Very good. But if you recall this question, here, here we have converted your nitro to, but here they are saying that Cl2 AlCl3 is okay. But this question also I have taken it from book only. I will check again, but chlorination can be done. Okay. But here, see, among these four options, we have to see most appropriate one. So only plausible reason for one being wrong is this. Yes or no? Oh, have you understood, student? If not, you can ask me.
Ma'am, once more, can you explain?
I was saying, in that case, in earlier case, chlorination was possible on benzene ring. Yes. Here also, four options are there, but we have to go with most appropriate option. So in exam also, if you get four options which are equally probable, you have to see or look for most appropriate option. Why option number one is not correct? Because let's say it is giving product of that Friedel-Crafts product from this nitrobenzene, but yield will be very much less. Why? Because this ring is deactivated by your nitro group. This I am telling. Now tell me why option number two is not correct. Who is going to solve? Just try. Why? Question to this answer also I have told you in last class. In Friedel-Crafts alkylation, what extra reaction also takes place? Am I audible?
Then product is nitro group is at meta position and alkyl group is also para-directing.
Very good, very good. She is saying correctly. She is saying that you will get this product, but this is now ortho para directing. But we need here meta to each other. Yes or no? And one more thing is also there. Let's say carbocation form here. It can rearrange also. Yes or no? By 1 to hydride shift. And now this can also attack. But most appropriate reason is that it is ortho para directing. Very good. And why option number C is not correct? In option number C, in first step you will get CO, CH2, CH3. Is this group is meta directing or leave it? Before it, tell me, is it electron donating group or electron withdrawing group?
Electron withdrawing.
Very good. And over that, it is inviting NO2 to come, which can't be possible. Yes or no? So the only correct answer is HNO3, H2SO4. Here I am having one doubt. We have to wait. HNO3, H2SO4, then they are doing it hydrazine hydrate. Okay. And in next step, they are doing it HNO3, H2SO4. Then they are acylating it CO, CH2, CH3. And what can anyone know what is the role of hydrogen hydrate?
Reducing agent.
What it does and what is the name reaction?
Wolf Krishna reduction.
Very good. And
Yes.
what is that ZnHgHCl?
Clemenson reduction.
When do we use this Wolff-Kishner reduction? And when do we use Clemenson reduction? So basically, this reaction is it converts your carbonyl to alkyl chain. Yes or no?
Yes, ma'am.
So one condition is acidic and another condition is basic. Okay. So whenever you are, let's say you are having acid sensitive groups in your benzene ring. So which condition will you use? Wolff-Kishner or Clemenson? Can I repeat my question? Let's say you are having for reduction of this carbonyl, will you use Clemenson reduction or this Wolff-Kishner reduction? No? Anyone? Try. Don't you think this is your acid sensitive group? Since ZnHgHCl contains acidic HCl, it can it can remove it as a H2O and carbocation can form here. Yes or no? So for these condition, which functional group, which reagent will you use? This Wolff-Kishner reduction. Okay, student. If there is any doubt, you can ask.
Ma'am, repeat again.
Okay, let me erase all this. Then you can. I am asking. Let's say there are two cases. You have your carbonyl COCH3. You have your carbonyl here COCH3. Okay. And let's say you are having OH. Here, let's say you are having CO2 ET. I am asking if you want to reduce this carbonyl to alkyl chain, you can use two things. One is your ZnHg HCl. You have told me that it is Clemenson reduction. And you can also use your Wolff-Kishner reagent. I am asking if you want to do reduction of this problem number 1, which reagent is more suitable for this reduction? First one Clemenson or this Wolff-Kishner reduction? Okay, leave it. What I want to convey from here is if you have any acid sensitive group attached to your benzene ring, then you can't use Clemenson reduction because it will bring changes in other groups also, right? So for that condition you have to use hydrazine hydrate condition. This is basic condition, and this reduction is acidic condition. So, if you have any substituent attached to your benzene ring that is acid sensitive, for those cases we will use Wolff-Kishner reduction. If there is anything in your benzene ring which is base sensitive, for that we will use zinc reduction, Clemmensen. Why? So that that substituent can't be affected by reduction condition. Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, I know you have not understood clearly, but listen again this video and then you will find it helpful. Okay, so that was a recap for last week, electrophilic aromatic substitution. I hope you are clear with your NMR and electrophilic aromatic substitution. Yes or no?
Yes, ma'am.
If you are
Yes,
clear,
ma'am.
if you are clear at your NMR, let me take a quick test for you. Okay. Benzene protons. Where? What is the chemical shift of benzene protons?
7.26.
No, that is the CdCl3. Okay, you are telling me 7.26, right? 7.26 is okay. In general, we in NMR we use CdCl3. Okay, that is deuterated solvent. But you know, while making CdCl3, there are trace impurities of chloroform also. Because from chloroform only you are forming deuterated CdCl3, right? So that chloroform hydrogen peak comes at 7.26 ppm that he is telling. I am asking range for benzene protons, that is 7 to 8. Okay, 7 to 8 ppm. Okay,
Okay.
then tell me where acid proton comes in proton NMR. COOH,
10 to 12, 8 to 10.
that is 10 to 12, right?
Yes, ma'am.
Okay. In every class, I'm going to take your small test. So come with your revised notes. Okay. Okay. Aldehyde protons.
8 to 10.
Very good. 8 to 10. Your
8 to 10.
olefinic range, simple olefin alkenes.
Not 4 to 6.
Swastika is saying 4 to 6. Okay. And your carbon, sp3 carbon hydrogen, but attached to any heteroatom.
3 to
2 to
4.
3.
Very good. Your simple primary carbon hydrogen.
0 to 1.
3.
Now, that is your primary hydrogen 0.9, secondary 1.3, tertiary
7.
1.7. Very
7.
good, very good. Okay, now let's come to carbon. Where at carbon reference peak comes, like you told me in proton NMR, it comes at 7.26. Okay, so in carbon, okay, let me go to slides. My slide is visible, right?
Yes, ma'am.
So if you look at carbon spectra, student, okay, one triplet will come. Have, has anyone seen 13C spectra anytime? If not, I will leave this topic. Just tell me, has anyone seen spectra for 13C?
Yes, ma'am.
Yes, okay. If yes, can anyone tell me why this triplet comes? And it is near 77 range. Middle peak is 77.16. It is near to 77 point. Now tell me why this triplet come. Can anyone tell me?
Ma'am, due to solvent,
Due to solvent. Which solvent generally we use here? Okay, one student is telling me due to solvent. Okay, what do we have in general solvent? CdCl3. Okay. Now, student, can anyone tell me I value for deuterium? That
0.
is,
Ma'am,
no,
1.
1, 1. And you know that splitting takes place like this 2i plus 1. So 2 into 1 plus 1, 3. Therefore, triplet comes. Yes or no?
Yes.
Therefore, in 13C spectra, you can see one triplet is there which is corresponds to your CdCl3, not your chloroform. Remember, in proton spectra at 7.26, one singlet is there. That corresponds to trace impurities of chloroform in CdCl3. But 13C is, abundance of carbon is relative abundance of carbon. 13 with respect to 12, carbon 12. Anyone? Quickly. That is 1.1%.
1
So
point.
in order to get this trace impurities chloroform, this should be in more quantity, but it is in trace amount, so it doesn't come in your 13C spectra. This peak comes only in your proton spectra. Yes or no? But in your 13C, CdCl3 peak comes because this carbon is attached to your deuterium. That splits it into 2i plus 1. I is 1. Why? Because deuterium is having even mass. 2 into 1 plus 1, that is 3. Therefore, you are getting triplet. Understood? Fast? Bolo.
Yes, ma'am.
Okay. Okay. So we will revise at the end of the class. Let's finish this part. At the end of the class, I will ask whatever I have taught to you in last week and before this slide. Okay. So be ready for that. Okay. Now comes nucleophilic aromatic substitution. But how it is possible? Because nucleophile is your electron rich and ring is also aromatic. Aromatic rings are also electron rich. How like charges are going to react with each other in organic reactions? Any idea? It means we have to do some manipulation to benzene ring. Yes or no?
Yes, ma'am.
So, nucleophilic aromatic substitution reaction can be of two types. One is your addition, then elimination. Okay. If we are starting this, you can see you are having NO2. Okay. Before it, what is the name of topic? Nucleophilic aromatic substitution. It means your nucleophile is going to displace one of the atom, right? Or not atom, one of the nucleophile. Nucleophilic aromatic substitution. Okay. See here, nitro group is beneficial or not beneficial. Here it will be beneficial. Why? Because now you are inviting Ambani to your home. When Ambani will come to, okay, leave about Ambani. If we can talk in organic terms, we know opposite attracts. Yes or no? Not in organic, in nature also. Opposite attracts. So, if you are inviting any external nucleophile, your benzene ring should be electron deficient or electron rich.
electron deficient.
Electron rich.
Someone told me electron rich. How? If you are inviting external nucleophile, listen, Nucleophile is electron rich. Your benzene should be electron deficient. More, let me write here. More the ring will be electron deficient, higher is the rate for. This is very important topic. Okay, if anything is not clear, please ask me. Higher is the rate for your nucleophilic aromatic substitution. You will get many condition where you have to figure out in under which condition your nucleophile will substitute, under condition addition then elimination or elimination then addition. For that, first consideration in addition then elimination is your ring should have electron withdrawing group. Okay. Okay, so this is your. So, if you are adding external nucleophile, first it will add. Add in which fashion? Here positive will come, here negative will come. Okay. OH attached to a ring. Then this negative charge will delocalize. This negative charge can be stabilized by your nitro group. That is your Mesenheimer complex. And at last, what will be there? This negative charge will knock off fluorine, elimination will be done, and you will get this aromaticity is back. Has everyone understood this mechanism for addition then elimination? Why it is calling it addition then elimination? Because it is not directly eliminating fluorine. It is first adding to it, and after getting resonatingly stabilized, in last it is removing. Therefore, it is addition then elimination. Understood?
Yes,
Okay.
ma'am.
Okay. Another is your elimination then addition. Now you will ask, ma'am, how we will know whether it is elimination, then addition, or okay. So for that, one most key feature of benzyne mechanism is you will get strong base as your reagent. Okay. If anyone recalls, NaNH2 is a strong base. Yes or no?
Yes, ma'am.
Why strong base? Because everyone knows. Let's say this is OH minus. Either it will be NaOH, KOH, yes or no. But here it is NaNH2. Benzene protons are sp2. Benzenic protons are attached to sp2 carbon. So it is not that much easy to abstract this proton. In order to abstract this proton, you need a strong base. Yes or no? That can abstract and it can knock off this halogen atom. So two conditions we get. First one is your base should be strong, and second is your there should be good leaving group. Yes or no?
Yes, ma'am.
Okay. So first one is your deprotonation, then knocking off that halogen from ring, formation of benzyne intermediate, and followed by nucleophilic attack. If you want to again break this bond, positive negative will be quenched by your water H plus, and negative will be, and that positive charge will be attacked by your external nucleophile. In NaNH2, what is nucleophile? NH2 only, right? So you will get this, instead of halogen you will get this aniline. I hope you have understood.
Ma'am, after benzyme,
Hmm.
repeat please.
Okay, I can repeat. See, you are having this benzene. Till now, clear? This is a simple benzene ring. One more
Yes,
bond
ma'am.
is there. Okay, you know that alkyne needs what angle? SP. Alkyne is a hybridization is SP. It normal angle is 180-degree.
Yes,
But in benzene ring, it is having too much strain, so it is highly reactive intermediate. Now, if you break this
ma'am.
bond, it will be like your positive, negative. Yes or no? We can write double bond like this. Positive, negative.
Yes, ma'am.
Huh. So now nucleophile is your negatively charged species. It will attack this positive part. And this negative will be quenched by your water. Water have H plus OH negative. And this negative charge will take H plus from your workup and you will get this aniline. Now understood?
Yes, ma'am.
Okay. Sure now?
Sure, ma'am.
Okay. So shall we move to problems now? If you have any doubt, ask me here. Okay. Choose the correct option regarding SNAR. Another name for nucleophilic aromatic substitution is SNAR. Here, electron withdrawing. Okay, this is your abbreviations. So first, in option number 1, it is saying more the number of electron withdrawing at ortho and para position to halogen atom. Okay, what they are saying, student? Ortho, para, electron withdrawing group. Faster is the reaction. Are they saying correct? In option number A, they are saying more the number of electron withdrawing group at ortho and para position to the halogen atom. To the halogen atom, faster is the reaction. Yes or no? Okay. Before that, is it addition then elimination or sorry, it is addition then elimination or via benzyne?
Addition then elimination.
Addition then elimination. Very good. Now tell me, is statement A is correct? Correct, na?
Yes, ma'am.
Electron withdrawing group are going to stabilize your carbon ion. Yes or no? This carbon ion. Why it is forming? Because if you break this double bond, positive, negative, positive will be attacked by your nucleophile, and this negative charge will delocalize. Yes or no?
Yes, ma'am.
Yes, ma'am.
Huh.
Yes, ma'am.
Therefore, option A is correct. Okay. Now let's read another statement. Less the number of electron withdrawing at ortho and para position to halogen atom, faster is the reaction. Yes or no?
No, ma'am.
Very
No,
good.
ma'am.
In C option, they are saying more the number of electron donating group at ortho and para position, faster is the reaction. Yes or no?
No,
No,
ma'am.
ma'am.
No. So only correct answer is option number A.
Eh,
Okay. Shall we move ahead?
yes, ma'am.
Okay.
Yes, ma'am.
Good. So, who is going to answer me this question? Before answering, my first question is which mechanism it will follow? Addition, then elimination, or benzyne? Ben, one thing is you examiner may confuse you by saying benzyne. Benzyne mechanism only. Benzyne is the another name for elimination then addition. Okay. Later in slides, I will tell you the exact mechanism for benzyne. Okay, elimination then addition. It is another name for elimination then addition. So don't confuse. They are equal. Okay. Now tell me, in this question, what will happen? Addition then elimination or via benzyne?
Elimination then addition.
Huh? Addition then elimination. Yeah, you are correct. Now tell me which option is correct. Whoever is answering, tell me with reason. I will give 5 point to that person. That's a very good problem. It will be very helpful in your exam also. At the end of this course, you are going to give an exam, right? If I'm not wrong.
Ma'am, option A.
Option A. Okay. Option one student is saying option A. Okay.
Yes,
Ma'am,
ma'am.
option A.
Everyone
Option.
is with option A.
Option B, ma'am.
A, ma'am.
A, B. A को two vote, B को one. Okay. So that I can know the name at least, because you are not going to tell me your name. Who is going to tell me the reason behind any option which you are giving? Silence is there. Tell me na why you are with that option. Shubham,
मैम मैम ऑप्शन बी होगा.
option B. Okay. And that,
Due to natural group will deactivate at ortho and para position, so para position first attack OCH3 minus addition takes place.
very good. Very good, Shubham. That means you are active in class. What he is saying that this nitro, if you recall from your electrophilic aromatic substitution, it okay. If you can see the mechanism, you are seeing that this nitro group is stabilizing your carbon ion, right? But if you look at resonating structure, in no structure this negative charge is coming at meta position. Yes or no? This negative charge is only coming at ortho and para position to your leaving group. Okay. So in this question also, you have to eliminate one of the group, but negative charge will not come at this position if you are removing these two chlorine. So only nucleophile which can be substituted is para 1. So the correct answer is option number B. Who told me option number B? Option number B. Who has given me answer? Because only one person was telling option B.
Others,
It's
ma'am.
me, ma'am.
Adarsh. But Shubham, your reason was nearer to this and you are answering A. Why?
Ma'am, first be confused and answer A, then we revise previous slide, then
Because
option B.
because if we look at mechanism, that negative charge is at ortho and para position. So for addition then elimination, one condition is leaving group should be good. That is same condition in both. But another condition is what? Your electron withdrawing group should be ortho or para to leaving group. Understood?
Yes, ma'am.
So Adarsh, you were telling. Adarsh got 5 points. Very good. Okay. Problem number 6. Which of the following reactions are not feasible? These are your options. Okay. F- One by one, you tell me. In option number A, what type of reaction it is? Type 1 or type 2? Let me clear here. Type 1 is addition, then elimination, and type 2 is your benzyne. Now, here 5 points are for telling me correctly that give me 1 minute. Now tell me, option number A, which type of mechanism will operate, type 1 or type 2?
Type 2, ma'am, because K is strong base NH2 minus eliminates here.
Okay, your name?
Shubham.
Okay, Shubham. Shubham is saying type 2 and he is correct, because one thing is there are no electron withdrawing group attached to your benzene ring. Okay, and another thing is strong base is there. Okay, good. In option number 2, type 1, type 2, or none of these?
Type 2.
Yes, ma'am. Type 2.
But if you are saying type 2, but okay, I think you are answering because now you don't know the exact mechanism. But I have shown you in front, I think so. Huh. See, students, in type 2 also, you should have adjacent proton, right? Then only it can form benzene. Yes or no? Because base is going to abstract this proton, then it can eliminate your X group, then you will form benzene. So, student, when you are answering, only then you can unmute yourself because it is creating echo. Okay, so kindly mute yourself. When you are answering, just unmute and then again mute yourself. Huh. So I was explaining to you in this B part, there are no देखो, a type 1 is not possible because there are no electron withdrawing group, and if we can see, these methyl groups are electron donating via plus inductive. But type 2 they are not having adjacent protons, correct? So this reaction is not feasible, and this is multiple option. Option number A is correct, but our main question is reactions are not feasible. So option B is correct because yes, this reaction is not feasible. Option number C, is it correct?
Yes, ma'am. Is also correct.
Huh. Why? Because again, there it is not having adjacent protons. Option number D,
And it is not feasible.
it is it is not visible.
Yes, ma'am. Lower part no visible.
Okay, okay. This is like this. OCH3. Now tell me. If one thing you can notice is all the four options are going via benzene mechanism. Only A reaction can take place because it is having orthoprotons available. But in D also orthoprotons are not there. Yes or no?
Yes, ma'am.
And one more thing, orthoproton should be available at leaving group position. Okay, ortho to the benzene mechanism needs leaving group, ortho to, okay, orthoproton should be present at leaving group. What I'm saying, this is our leaving group. These protons should be there for benzene mechanism to operate. Okay, understood?
Yes.
Problem number 7, integer type question it is. Identify number of reaction that can give nucleophilic aromatic substitution product. Student, one thing which I can recommend you is that whatever question I am giving to you for solving, you just write in your notebook 1 to 10 and write your option whatever you are getting at first time, and at last match how many question you are doing correctly. Okay, that will help you to solve that MCQ type questions, and this integer type question also came in your exam. Okay, and at last match those answers in how many questions you were accurate. Okay, so who is going to tell me? They are asking identify number of reaction that can give nucleophilic aromatic substitution. Nucleophilic aromatic substitution covers both type, so you have to tell me which mechanism is operating and the reaction which are feasible for this nucleophilic aromatic substitution. You know everything. Take your time, take 1 minute time and tell me. Tell me your name and then start answering. And if you are saying this, ma'am, this reaction is not feasible, give me reason.
Ma'am, D is not feasible.
Uh, D, but first question is number of reactions that can give. So it is NAD type. First, give me values 1 to 6. Which digit will you choose? Not feasible, we will discuss later. How many reactions are feasible? Count and tell.
Ma'am, total 5.
5. Your name?
Subham.
Okay, Shubham is saying 5. That girl who was there, I think she was saying two reactions are not feasible. Yes or no?
No, ma'am, I told only one, that is D.
That is D, that is not feasible. Okay. It means your answer is also 5.
Ma'am, I'm not sure about B.
Okay. No issue. Another answer? Okay, let's check one by one. In option number A, type 1, type 2.
Type 1.
That means addition then
Type 1
elimination.
means.
Very good, very good. So it is feasible, right? It will add. This NO2 will stabilize that negative charge, and you will, at last, this chlorine will eliminate and OCH3 will come. So it is correct. Option number B is also correct, right? This is addition then elimination. These are also electron withdrawing groups, yes or no? They can also stabilize that negative charge. So option number B is also correct. Option number C, which operation?
Type 1 means.
Type 1. Why?
Type 1.
We know that this NO2 is at meta, but the base is not that much strong that can abstract this proton and go via benzyne mechanism. But type 1 is there because NO2 is also having minus I. Okay. So, okay, C is also operative. D, this is your
Not.
electrophilic aromatic substitution, not
Yes,
nucleophilic
ma'am.
aromatic. E, yes, it can go through benzyne mechanism. F, which mechanism will
Type 1.
operate?
Type
Type 1.
1.
Type 1. Very good. So, correct answer is 5. Very nice. Next problem. The following compound will undergo electrophilic substitution more readily than benzene.
Ma'am, can please show previous slide?
Okay. This or I should
Yes,
go
go ahead.
go ahead. Okay.
Yes, ma'am. For a screenshot, ma'am.
Okay. They will. I think they will provide you these slides, na, with annotation only.
But ma'am, there's slide only question, not explanation. Erase all thing what you write.
No, I have. Okay. I think sorry. At last time I forgot to save these annotation. This time I will save this annotation and then I will upload. Okay.
Okay, ma'am.
Okay. For last time, I'm sorry. I think I have uploaded only question slides, right?
Yes, ma'am.
Okay, I will see that. Okay, now tell me the following compound which will undergo electrophilic aromatic substitution more readily than benzene. They are asking which are more reactive than this benzene among these four options for electrophilic aromatic substitution.
Ma'am,
Phenol.
phenol.
Phenol, very good. It was very easy question. So, see, if you know the concept, only this, not that much easy, but competitive exam just check your concept. Okay, you know that electrophilic aromatic substitution will prefer electron rich ring. So, who are electron rich than benzene? Anything which are having either plus I or plus M. Okay. Very good. This you should solve this question in 30 seconds. The major product obtained when Br2Fe is treated with this compound. This is from IIT paper. Quickly. Okay, before answering, this is from which concept? Electrophilic aromatic or nucleophilic aromatic?
Electrophilic aromatic,
Very
ma'am.
good. Now, quickly, which option? Fast. Okay.
Ma'am, maybe option number A.
Option number A.
I'm not confirmed now.
But why not confirm? You are absolutely correct. See, this is your NH. This is your CO. If you talk about this ring, na, this ring is connected to NH, which is your plus. Oh, sorry for that. This NH is your, this ring is having plus M. But if you look at ring B, this is connected to carbonyl C double bond O. For this ring, there is minus M. So if we do a competition between ring A and B, ring A is more reactive, right or no? Now, this NH is ortho-para-directing group, so obviously it will invite incoming electrophile at para position. So option number A is correct. Now tell me, is anyone why you were having doubt? Okay, let me clear you. If you are having this type of fuse system, you just have to check connectivity, which atom is connected to your benzene ring. This benzene ring is connected to lone pair containing atom. Let's say you are having this NHCOCH3, NHCOCH3, and you are having CONH2. Student, this is your plus M group and this is your minus M group. Why? Because now C double bond O is connected to your benzene ring. If you draw resonating structure, plus will come here, negative will come here. So your benzene ring will have net positive charge. Yes or no?
Yes, ma'am.
Therefore, correct option is option number A. If anyone is not clear, please tell me. And if I'm going too fast, you can ask me, I will slow down. But I know you know all these concepts, plus M, minus M. You just have to see the substituent attached to your benzene ring, find out whether it is plus M or minus M, and just tell the answer. Okay?
Yes, ma'am.
Okay, good, very good. So, this is from your nucleophilic aromatic substitution. Why? Because they are saying SN, substitution, nucleophilic, aromatic. Now tell me, which is correct? Okay, before that, it is addition then elimination or elimination then addition?
Addition then elimination.
Addition and elimination.
Okay, that is good. Now tell me. Okay, for answering this question, just have a glance to this slide. See for 10 seconds this addition elimination part. Focus on this part. You have scanned this slide in your memory. See the mechanism, how it is going through. Okay, according to you, which is RDS? RDS means rate determining step. Addition of nucleophile or leaving group elimination?
Addition of nucleo.
Why? Because your aromatic ring is wait. This is your starting material, this is your product, let's say. And if we talk about intermediate, this is energy of your starting material, right? And this is your intermediate. In starting, your benzene ring is aromatic. You have to give energy to go from this intermediate, right? So this is your rate determining step. But from coming to intermediate to product, you don't have to give energy, right? Because your product is more stable than your intermediate, right? So your RDS is addition of nucleophile. Now tell me, but the role of X is in leaving group, right? Because that negative charge is handled by this nitro group, yes or no? Negative charge in that intermediate structure. Let me draw. This is your X, this is your NO2. Electrophile is here. Negative charge is here. Okay. Role of your this is in leaving group. Now tell me answer. I have given you enough hint. It is asking reactivity towards S and AR. Shubham, Adarsh,
Ma'am, rate of fluorine leaving group will be fast.
So this is living to ability upon.
could you please repeat? You are saying that rate will depend upon leaving group ability. Okay, with
Yes, sir.
keeping this point in mind, which is correct option? You just have to match. A should be with P or S.
P.
And P, ma'am.
So you are saying fluorine is a good leaving group than these. Okay, let's have this as a homework question. Think about this question and then tell me in next class. Please remind me in next class we will discuss this question again. Okay?
Okay,
Just
ma'am.
think. Read more about addition than elimination, then answer this question. Okay? Okay. Which one of the following form benzene as an intermediate when treated with KNH2 in liquid ammonia? KNH2 is potassium amide. Sorry. Potassium amide. Yeah. Who will form benzene intermediate? Very easy question.
Option second, ma'am.
Option second. Okay. Why not option A? Sorry. Why not option 1, 3, and 4?
Ma'am, aldehyde is in first option electron withdrawing. So we first take addition, then elimination.
Okay. Another answers. Okay. Let's see the mechanism for benzene. This is your X. This is your, let's say, anything group. Okay. hydrogen, hydrogen. In first step, what you are doing? Deprotonation and formation of benzene. Yes or no? Then you are adding nucleophile. Nucleophile can attack in two ways. Let's say if you are having positive here, negative here. So positive will be attacked by your nucleophile, negative charge. Another condition, you are having nucleophile here and negative charge here. G group is here. Okay. Now tell me which can form benzene as an intermediate when treated with KNH2. You should remember one thing in your benzene intermediate is that, student, this negative charge is not in the plane of the ring. Okay. See, your benzene ring is planar, right? This negative charge is not in the plane of the ring. Means in whenever you are having benzene as an intermediate, you should not look for minus m or plus m. Okay. Here only effect that predominates is minus I, because only from minus I you can stabilize this negative charge. How can you stabilize this negative charge? By having minus I groups which can be electron withdrawing, right? OCH3 is having minus I or
Yes,
plus
ma'am.
I. It is having minus I. It is having plus M. Okay, but if we look at inductive effect, OCH3 is minus I. Yes
Hmm.
or no? NO2
Yes,
is
ma'am.
your minus I minus M. This is again minus I minus M. This is minus M. If you look at all the option, in all the option it can form benzene. Yes or no?
Yes, ma'am.
Huh. So whenever you are going through benzene mechanism, look for minus I. Keep this line bold. You should remember this every time. In your benzene intermediate, you should not look for mesomeric effect, because for mesomeric effect, your lone pair should be in your benzene ring, but this is not in the plane of the ring. Not in the plane of the ring means group attached to it can't stabilize that negative charge with its mesomeric effect. Okay, I hope you have understood.
Yes, ma'am.
Here, tell me major product. Very good question. But before that, I will show you how to solve this question by solving question number 1. Another two you will solve. Okay. First step is your deprotonation. So you can get two structures. OCH3. One is your this. Okay. But we can also write this structure of starting material 1. Sorry, I have redrawn this only. We can also write in this form. Yes or no? What is the difference between these two? These double bonds have been rearranged. But these are same, yes or no?
Yes, ma'am.
Huh.
Same.
So if we go by this way, then it can have this benzene also possible. Sorry. Another possibility is Yes or no? Now you have to attack NH2. Where NH2 will attack? Here or here? And why? In if we go via A structure. At position number 1 or 2, where NH2 will attack? Student, it will attack at position number 1. Why? Let me tell you. If it attacks at position number 1, negative charge will come here, and you know very well that in benzene which effect predominates? Minus I. In every example of benzene, minus I. And inductive is distance dependent effect. Yes or no? More this
Yes,
group is
ma'am.
closer to this negative charge, more it will stabilize. OCH3 is minus I. It will stabilize this negative charge. So you will get this product if you are getting this benzene. Correct?
Yes, ma'am.
But if you are looking at this,
Hmm.
then this negative charge will be stable here and your NH2 will be here. Now this negative charge is more stable. So which product will you get? This one. Okay? Because this proton is more acidic instead of this due to having two electron withdrawing groups. If we talk in terms of inductive. Understood? That's why meta product is major. How you will get? You have to draw both the structures, then you have to draw benzene, and you have to stable this negative charge. This negative charge can be stabilized only by your inductive effect. Inductive effect goes via distance. More it is closer to negative charge, more it will stabilize your carbanion on the benzene ring. I think you are not clear or clear. Okay, if you have understood little bit, can you try second one? Okay, are you clear that this why this proton is more acidic? This is your Ha, this is your Hb. Are you clear why Ha is okay? How do you determine acidic strength? Conjugate base of that acid should be stable, yes or no? If we go from general organic chemistry.
Yes, ma'am.
Okay, very good. So where this anion is stable? Here or here? Here, because this anion stability we are looking by inductive. Since this negative charge is not in the plane of the ring, it can only
Hmm.
be stabilized by inductive. This OCH3 is minus I, chlorine is minus I. 2 electron withdrawing group can stabilize this negative charge. Therefore, this is more acidic. If it is acidic, benzene will form like this. Okay? Then there are two possibility. NH2 can attack here, NH2 can attack here. If it is attacking here, negative charge will be near to OCH3. That can stabilize it. Therefore, this is major. Now understood?
Yes, ma'am.
Sure. If not, I will explain again. No issue.
And please, one again.
Okay. I will go slowly. Wait. See. What is your first step in benzene? You have to abstract a proton. Okay. So base will abstract a proton from most Base will abstract most acidic proton. Yes or no? So, first you have to decide which proton is most acidic. So, among HA and HB, proton HA is acidic. Is this thing clear to everyone?
Yes, ma'am.
Yes,
Okay.
ma'am.
Yes.
Okay. If this thing is clear, negative charge will come here. It will knock off this chlorine and will form benzene. And you will get this structure. Is this clear?
Yes, ma'am.
Okay. Now there are two possibility. One is this and another one is, let me draw. If you draw in your copy and solve by yourself, it will be more clear. Trust me. OCH3, and another possibility is that negative charge is here and NH2 is here because NH2 is negatively charged. So positive charge will be taken by your NH2. Now tell me, among structure A and B, which is more stable? A or B?
A.
A, due to minus I effect of OCH3. Therefore, at last in workup, it will take H and you will get this product. Now, clear? So, first thing you
Yes,
have to
ma'am.
see is most acidic proton form benzene, and at last you have to see which group can stabilize that negative charge after attack of nucleophile. Okay, clear? Still not clear.
I'm clear.
If clear, tell me in this problem number 2 where NH2 will be there.
I'm in para position.
Yeah, you are correct. How? First, it will form benzene here. Yes or no? Negative charge will be stabilized here because here NH2 will come and this negative charge is stable. Therefore, you will get this NH2 at para position. Clear?
Yes, ma'am.
Okay. In third step, you will get benzene. Only condition is this. From here you can form benzene, right? Because this is orthoproton to your leaving group. So let me draw for you. In third case, you will get this benzene. You have to rearrange this double bond, then you will get to know that this benzene will form. And if this benzene is forming, obviously in first it is meta, so here also it will form meta because benzene is same. Yes or no? I hope this slide is clear. Again, go through this slide, you will be more clear. Okay, if there is any doubt, ask me, I will tell you again. Okay, why I am seeing it adjacent? If you recall your mechanism, this is your chlorine, this is your hydrogen, this is your first step is proton abstraction. Now this negative charge will go there and eliminate. Okay, so negative charge is here, this chlorine is there. Chlorine will knock off as Cl negative. It will leave here positive charge. Yes or no? You just have to see from where benzene can form. Obviously, benzene will form from adjacent positive negative. So, in order to get adjacent positive negative, you have to redraw this structure like this way: OMe, chlorine, hydrogen. These two structures are equivalent. Yes or no? They
Yes, ma'am.
questioner. The person who has made this question has drawn it like in that way in order to confuse you. Okay, but you have to see the both the possibility. How can you get rid of this confusion? you just don't see the double bond, you just see which proton is more acidic among all the. So here this is most acidic, and here this is most acidic. Okay, but apart from being acidic, it should be adjacent to your halogen atom. Now clear?
Yes, ma'am.
Okay. Okay, I think sir has also covered IR, infrared spectroscopy, in I think last slides. Yes or no? No? If no, this will be your HW. You should go through sir's slide and read about IR spectrum, infrared spectroscopy. Let me recall you, it is having two group, functional group region, fingerprint region. IR is also a type of spectroscopy which can help to analyze the structure of your unknown compound. Let's say you are given unknown compound. You know NMR technique. Another technique to analyze is your infrared spectroscopy, because different functional group give different absorb different wavelength frequency. Yes or no? So student, 4000 centimeter inverse to your 400 centimeter inverse. This is your wave number, right? Wave number, how I'm calling? You know wavelength. Wavelength SI unit is meter. If you are doing 1 by wavelength, this is your wave number. If you recall your 12th class, yes or no?
Yes, ma'am.
So there are two regions. Have you not gone through sir's lecture, everyone? Because you are blank in IR. No one is giving any response.
Now don't study ma'am infrared, so don't know about the concept of infrared.
Okay. I'm giving here brief introduction, but you please go through sir's slide also. Okay. So students, in there are, okay. Do you know about anything about electromagnetic spectrum? That Vibgyor, sorry, forget about Vibgyor. That X-ray, gamma rays, X-rays, UV,
Yes,
visible,
ma'am.
then
Yes, ma'am.
Yes,
infrared,
ma'am.
Yes,
then
ma'am.
microwave, then radio waves. NMR needs radio waves. IR is in range of, and that is in order of wavelength. Your radio waves have least wavelength or highest wavelength.
Least wavelength, ma'am. Radio wave.
Least wavelength.
Ruk. Radio waves. Can anyone tell me order radio waves after that?
And microwaves,
Microwaves, very good. After that,
infrared,
Infrared.
very good.
infrared,
Now you are
visible
speaking.
light,
Infrared, visible,
visible
then
light,
your UV, then
UV,
your
X-ray,
X-ray,
X-ray.
then your
gamma ray,
gamma.
Gamma ray.
and cosmic.
You know gamma rays. Okay, let's say you don't know anything about range, but you know one thing, that gamma rays will have maximum energy, right? Gamma rays. Okay, maximum energy means maximum frequency, yani
Hmm.
means least wavelength.
Least.
And in instead of this radio waves, they are having highest wavelength but least energy. Therefore, whenever you are taking your compound for NMR, it is not getting destroyed. Yes or no? Because it is using radio waves. So when you come up to down, wavelength increases, energy decreases. Yes or no?
Yes, ma'am.
Good.
Yes.
Your homework is, you should know which frequency range these are having. Okay. For example, I'm telling you for infrared 4000 centimeter inverse to 400. Okay, so students, I think huh, 1400 to 400, this is your fingerprint region, and this is your 4000 to 1400 functional group region. In this region you can distinguish which functional group are there. Can anyone tell me in which range ketone is there? Okay, whoever has gone through sir's lecture, can anyone tell me, has sir covered this topic, IR spectroscopy?
Yes, ma'am.
If he has covered, student, I am requesting everyone, please go through his slide. Then we will do in next class. We will do this IR question only. Okay. You should know in which range ketone is there, in which range aldehyde is there, in which range ester alcohol. Okay. Only then it is beneficial to do questions, because without theory you can't do. Okay. So this slide I am keeping here as your homework. You have has anyone know that in 12th class also we have used this disonium chemistry.
Yes, ma'am.
Okay, what we used to do, we are given benzene, then we nitrate it by HNO3H2SO4, right? And then we used to do it. What we have to do with Na and okay. Then we used to do reduction and we got this aniline. And when we do that, NaNO2 in presence of HCl will give us HNO2. And you will get this benzene disonium chloride. Yes or no? Then by using that disonium salt, we can do various things. If you do CuCl in presence of HCl, which name reaction? Sandmeyer. Has anyone read in 12th class? Sandmeyer reaction.
Yeah.
Huh. CuCN in presence of, because this N2 is very good leaving group. Any nucleophile will come and it will displace N2. Yes or no? If you do H2SO4, this will form your phenol. HBF4 heat, aryl fluorides. If you do H3PO2, you will get your benzene back. If you do Ki, it will form potassium iodide. Sorry, it will form aryl iodide. Okay. I have given you one question in starting, right? That preparation of that compound from benzene. You can use this reaction also, CuCN1, because later you can hydrolyze it. Yes or no? Benzonitrile on hydration gives you benzoic acid. Understood? And this is the mechanism of this reaction. How aniline is converted into benzene disonium chloride, right? First, what will it will do? Okay, let me write. I am giving you brief recap because all these things you have studied in your 12th standard. On arrow it is written that NaNO2 HCl. So what it will do? It will form HNO2 and your salt NaCl. Till here it is clear? Since
Yes, ma'am.
huh. So you can write your HNO2 in this form. Okay. Now you know HCl is also there. Acidic medium is there. So it will protonate it. Okay. Now it will leave as H2O molecule and leave here NO plus NO. This nitronium ion. Understood? Which will be attacked by your lone pair of aniline nitrogen, and you will get this intermediate. This is its tautomer, 1,3 hydrogen migration. Type of ketoenol isomerism. Yes or no?
Yes, ma'am.
Huh. Then again, acidic media is there, protonation and leaving of this H2O molecule. will give you aryl diazonium salt. Okay, and this is very important precursor for functional group transformation. Yes or no? So you should remember this chart. Okay, understood? So
Yes, ma'am.
these are your answers. You can check. Oh, answer answer to the homework is also given. But I request everyone solve by yourself, then see the answer. Okay?
Okay, ma'am.
Huh. Please don't do cheating. Okay. If anyone is having doubt, you can ask.